Somebody reminded me. Thank you for reminding me. Okay, I will explain again. This computer A is communicating with the computer B. So when it is going through the computer A to B, we are using the TCP/IP protocol stack. In the TCP/IP protocol stack, we are using the digital data. Digital data is the 1010 like that. So if suppose it is an image, this image can be converted to digital data. So for instance, say that you have high definition TV, there the image is converted to pixel, and the pixels are sending as digital data, and it is coming to your TV. Right? Then this data is stored in the computer, and it is coming to the it is first coming to the application layer, then it is coming to the transport layer. It will put the transport header like that. It is coming down at the physical layer. It will put it to the transmission media. This transmission media can be copper cable, fiber, or free space. If it is copper cable, it is converted to electric signal. If it is fiber cable, this is converted to a optical signal. If it is wireless wireless signal, it is converted to wireless signal. So here up to physical layer, it is coming as the data. Then when it is going through the transmission media, it is converted to a signal. It is just like the data is just like the people. Signal is just like a vehicle. So people travel through the vehicle. Transmission media is just like a road. So that concept you can keep in your mind. That is the way we are sending our data from one place to another place. Then you see how if it is a voice signal. Now this is starting from the computer. Computer send this data from here to A to B. If somebody's voice want to send from this computer to, we call normally voice over IP, to the computer A to computer B, and the other person in the computer B connected there, he can listen to it. So a voice signal is not a voice. We have to convert it to digital data, digital signal, or the digital data. Okay. How we can convert a voice signal to digital data? And somebody answered earlier. How we can convert? Okay. And so also
the mic.
Yeah, you need a mic. Yes, yes.
To convert into an electrical signal and then
convert to digital signal. Yes, correct.
Yeah.
So today we are going to discuss about how it is done, how something like voice signal is converted to digital signal, and after that how this digital signal is digital data, then how this data is converted to signal, how the signal is going through the transmission media. When it is going through the transmission media, what kind of problems we are facing and what are the solutions for these problems. So these things we are discussing. Now this voice signal, yes, as you said, what we have to do is we are converting the voice signal. So voice signal by using microphone. So this is a voice signal. So we use a microphone and convert it to electric signal. When it converts in your mobile phone, there is a microphone. So it converted to electric signal. So this electrical signal, when you draw the voltage level in the y-axis and the time in the x-axis, it is varying like this. It is varying like this. So this signal is a continuous signal. There is no break in this signal. This kind of signal is called a digital signal. This kind of signal is called a digital signal. So when you have the voltage 1 and 0 like this is called, this signal is called the analog signal, not the digital. This is called analog signal. And if we have signal like the voltage 5 volt, 0 volt, so this kind of signal is called the digital signal. Right? Now you understand the difference between the analog signal and the digital signal. So if you want to send this voice through the computer, you have to convert your analog signal to a digital signal. You have to convert your analog signal to a digital signal. How you can convert this analog signal to digital signal? There are different methods. One method is called the pulse code modulation. One method is called the pulse code modulation. This is an example. The pulse code modulation is normally used for convert voice to digital signal. Voice signal to a digital signal. When you take a voice signal, the signal is from the 20 hertz to 20 kilohertz. The signal is having combination of frequencies. I will explain it later. Now, in the voice signal, it is from 20 hertz to 20 kilohertz, human voice signal. But for when we send the voice signal through the telephone, but you are selected only a particular bandwidth, that is 0.3 kilohertz to 3.4 kilohertz only. Only this frequency band we are using because that is sufficient to recognize the voice. So this is approximately 4 kilohertz bandwidth. Then this is the process. First we sample the signal, then we quantize, then we encode. So sampling means, so suppose this is your signal, we take this sample of the signal like this. So there is a theorem called the sampling theorem. Sampling rate should be greater than or equal to 2 times the highest frequency. So here, highest frequency is the 3.4 kilohertz. Then the sampling rate should be 2 times 3.4 kilohertz minimum. That is 6.8 kilohertz to recover this signal at the receiver. Because at the receiver, again, you convert this digital signal to analog signal, make an analog voice. So to get a faithful reproduction or the faithful signal in the receive side, this sampling rate should be greater than or equal to 2 times the highest frequency. So it should be minimum 6.8 kilohertz. Therefore, normally use the 8 kilohertz sampling rate. That means 8 kilohertz sampling rate means the 8,000 samples per second. So after we get in this sample, then we will quantize, we will cut it like this. So this is called the quantizing. This is called quantizing. After quantizing, we give a number to this quantizing level. 0, 1, 2, 3, 4, 5, like that. Then we measure what is the approximate quantizing level of this sample and give a binary number to this sample. Now this is 50. Then you have to convert this 50 to binary number. Then it will be 110010. When we convert, it's 50. It is 50. 50 converted to a binary number. The level is 50 here, approximate level. Then this is the binary number 110010. When we convert it into electrical signal, it is 0 volt, 5 volt, then 1, 1, 0, 0, 1, 0. So this is called a bit stream. So one binary number is called 1 bit. This is called a bit stream. So this quantization levels, number of quantization levels in the pulse code modulation is 2 to the power 8. Normally, you always get the multiples of 2. So, sampling rate is 2 to the, sorry, quantizing level is 2 to the power 8, that is 256 quantizing levels are there. 256 quantizing levels are there. To represent 256, actually 0 to 255, how many bits, minimum number of bits you require to represent 255, maximum 255? How many bits we required?
8.
Yeah, we need 8 bits. So this
2 to the power 8.
yeah, number of bits we required is the 8 bits. So we represent this in the number sampling is called the quantizing level as a binary number. Then one sample we convert to 8 bits. One sample we convert to 8 bits. The how many samples per second is there? 8,000 samples per second. Then how many bits are there? Each sample is 8 bits. Then it is 8,000 into 8 is 64,000 bits per second. In 1 second, we have 64,000 bits, or you can say it is 64 kilobit per second. Then this voice signal, analog signal, when we convert it to digital signal, it will become a 64 kilobit per second. So if we have analog signal, we have always converted it to a digital signal. So there are many methods to convert your analog signal to digital signal. So when you have your mobile phone, always your signal is converted to digital signal inside your mobile phone, right? Any question up here? Okay, I'll give a small question to you. Question is, so suppose you are recording a signal into a CD. So you want a high quality signal, therefore you are using 0 to 20 kilohertz bandwidth of your signal. 0 to 20 kilohertz voice signal. Signal is needed to convert to a digital signal by using PCM. PCM technology. Right? Can you say what will be the bit rate of this signal? It is 0 to 20 kilohertz. Can you calculate it? Do you need some more information to do it? The first thing you have to do is the sampling. How many samples will be there? Second thing is the quantizing. Third step is the encoding. Okay, what should be the minimum sampling rate here? Okay, first question is, what is the minimum sampling rate? Because we have to reconstruct the signal at the receiving end.
40 kilohertz.
Yeah, minimum sampling rate. How do you decide the minimum sampling rate? Okay, I will go to the book again. So minimum sampling rate, I mentioned that it should be 2 times the highest frequency. That is called the sampling theorem. It is 2 times highest frequency. Then what should be the minimum sampling rate? You can type your answer or you can tell me. Those who are answering will get more marks at the final exam. That means we are interactive and we are listening what I am telling. Yeah. Yes. Yes, answer is correct. 40 kilohertz, right? Then after sampling, what you do is the quantizing. You are doing the quantizing. I'll go to the book again. After sampling, you are doing the quantizing. This is quantizing. And I have to give you the how many quantizing levels are there. That information you require, right? Then now here you are taking the 256 quantizing levels. So that is 2 to the power 8. Therefore, you need the 8 bits. But I give you different quantization levels. That is, say 1024 quantization levels. When the number of quantization levels are increasing, the quality also increasing. Quantization levels. (1024). Then to show the number of quantizing levels, how many bits you require? This is
10
0
bits.
to 1023. How
10
many bits?
bits.
Yeah, correct.
10 bits.
Who is that? What is your name?
Fahima.
Okay. 10 bits. You need 10 bits. Right. Now, you know what is your sampling rate and how many bits are there in a one sample. Then can you calculate the bit rate? Bit rate equal sampling rate, how many samples are there, into quantization, number of bits in the quantization level. Right? That means the bits per sample. Okay. Can you write the answer then? What is the bit rate there? Should be the bit rate. So this is a song. It's a voice signal. We are getting the 0 to 20 kilohertz. Then we take the 1024 quantization levels. Then we need bit rate. Yes. Bit rate is 4000 bits per second. So if you use the 2048 quantization levels, that is 0 to 2047, what should be the bit rate? 2048 quantization levels. It is 0 to 2047. Can you
20
put the
bits.
answer? Yeah. What should be the bit rate?
20 bits.
8000.
Okay, you can type how much?
8,000.
So earlier was 400 kilobit per second here. Now here, okay, you can type your answer. Okay. Gayan's answer is correct. Okay, you can show that how you get the answer. Sampling rate is 40, it is not changing. Then how many bits in this one sample?
4 bits.
4 bits? 2 to the power 4 is 16. 8, yes, 16. This is 2014.
bits.
11 bit, yes, correct. Then what should be the bit rate? Yes, Gayan is correct. There are 11 bits. Number of sample is 47.
440.
Yeah, 440. Right? You will get some MCQs like that too, right? So then the sampling rate, the bit rate will be 440 kilobit per second. If it is 4096 samples per second, what should be the bit rate? Four 4096 samples
Sir.
per second. How many
12.
bits? Yeah, that 12 bits per sample. Yes, you need 12 bits. Then what should be the bit rate?
480.
180, correct. Okay, good. Right? Okay, I put it this way. There is a analog signal. We sample it in a sample. So it has a 50 kilohertz bandwidth. You need the quantization level 5 to 8. Can you tell me what should be the bit rate? You can take the minimum sampling rate. What is the bit rate? You can type it or you can tell me. Okay, I will put it this way. What should be the minimum sampling rate? Minimum sampling rate as per the sampling theorem, what should be the minimum sampling rate?
5 bits.
Sampling rate, not in bits. Please understand. Okay, so one answer is correct. Yes, sampling rate. As per the sampling theorem, sampling rate should be minimum sampling rate should be 2 times the highest frequency. Okay, so you should know that theory part. Okay, Subudhu correct. Shakti correct. Yes. Ranmuni correct. Okay, important thing is to understand these things. Yeah, it seems everybody understand that one now. It is 2 times the sampling rate. That is 50 kilohertz, 50,000 samples per second. Then this quantization level is 512. How many bits required to represent 512?
8 bits.
2 to the power 8 is how much?
9.
9.
9 bits.
Yes, correct. 9 bits. Then you know how many bits per sample. You know the number of samples per second, that is 100K. Then you know what is the number of bits per sample. Then what is the bit rate? Yes, Gayan is
900.
correct. Yeah,
ABS.
Piyumi correct.
900.
Yeah, 900. Okay, very good. I'm just giving this exercise just to keep you thinking. Think and understand. Not to search the Google and try to find out anything. So my MCQs also will be same, right? So that is about the converting your signal to your analog signal to digital signal. So always we are sending the digital signals through our network, right? So here we have application. In the application, first you have to take straight away digital data, or if it is analog signal, you can convert it to digital signal and store in your computer. So then that will come to the application layer. After that, it is come to the physical layer. Then physical layer convert it to a signal. So it can be digital signal or analog signal. Not necessary to be always the digital signal. In the wireless communication, it is going as analog signal. So I explained you about the digital signal and the analog signal. Now you should have idea about the signals. So then I can use the Perusan book for that purpose. The data communication and networking book you can use. In this book, you have this something called the data and signals. That is the chapter 3. Data and signals. Then I will go to the chapter 3. So this is very important. Understanding the data and the signal. This signal, it's a tangible thing. Actually, it's a electrical voltage or optical signal like that. Then the analog and digital signal. Now this is an analog signal. It's a continuous signal, you can see. And digital signal is discrete. Discrete means that it has definite levels. No need to be 2 levels. It's a binary. Yes, it's 2 levels. Okay. So normally actually we are using 2 level, but theoretically we can have any number of levels like this, right? It's not continuous signal like this. So there is a difference between the analog signal and the digital signal. Analog signal is a continuous signal, whereas digital signal is a discrete signal. We call it as discrete signal. Right. The question is asking encoding. Encoding means you convert this quantization level to a binary number. That's the encoding. Right. So after quantizing, you convert it to a binary number. How many bits are there? That is the encoding. Right. Now you understand this, the difference between the analog signal and the digital signal. Then there is something called the periodic analog signal. Periodic analog. You know what is the period? Period means it is repeating. Is that?
Excuse me,
Yes.
one question about the earlier slide you saw, about the digital signal. It shows, I mean, scale below 0, no? So
Scale below 0 means?
I mean, in the graph,
Which
the
graph?
the earlier one you saw.
In the my book or this Perusan book?
Oh, yeah, this book.
Ah.
Right, previous
Yes.
page? No, the previous,
Hmm.
this one. So
Hmm.
here this digital signal has a something below zero. No? Yeah, this
Yes.
part. Why below zero?
Yeah, there is a method to show that one. Now, suppose is it 256 levels, 128 positive, 128 negative. So you can put the first bit 0 if it is a positive. If it is negative, the first bit is most significant bit will be 1, something like that. So that is not necessary for this one, but it's a good question. That is the way it can be represented.
Okay, thanks.
Okay. Okay. Then so like that, I like to hear your questions. Then only I understand, you understand what I am telling, right? Now there is some small mathematical part here. When you take the analog signal, it can be a periodic signal. I think you studied about the periodic signal even in the A levels, if you have done the mathematics, but even the O levels, you talk about the periods. It is repeating. If something is if something is repeating, we call it as a cycle. Just like the bicycle. The cycle is it's rotating, it's repeating the same thing, right? So this signal, you can say it is very like this. This kind of signal is called the sinusoidal signal. In the mathematics, it is sine wave, sine signal, right? So this is called a sinusoidal signal. So when you are analyzing the signals, we are using the most simplest signal, that is the sinusoidal signals. So therefore, we study about the characteristics of this sinusoidal signal. This is very important, especially for the wireless communication. When you take this sinusoidal signal, it has some characteristics. One is the peak. So you can say this is the peak, this is the peak amplitude. This is the amplitude versus time. You draw this sinusoidal signal, y-axis amplitude, x-axis time, right? So it is very like this. Now this y-axis is amplitude, so it has a peak value. This is called the peak amplitude, right? There is a important thing about the amplitude. The amount of energy of a signal depends on the peak amplitude. If the amplitude is high, that means it has more energy, right? It is giving some indication about how much energy the signal has. Is it clear? So therefore, in this a sinusoidal wave, this amplitude gives some indication about the energy, right? Then period. Period means now when you take this signal, it is changing like this. Okay, I'll go to the sideboard. Right. So consider signal like this. So this is a sinusoidal signal. When you take from this point to this point, this is called one cycle. This is called one cycle. From here to here, it is one cycle. Also, you can take from here to here also one cycle. This also one cycle. The same thing is repeating again and again, right? So when you take a sinusoidal wave, so you have a cycle. You have cycle here. When you consider the y-axis as the time, so if it is time, how much it takes, it's called its period. How much it takes from here to here in time. say it is 1 second. 1 second. So that will be the period of the signal. Then this is a 1 cycle. So number of cycles per second in within 1 second, how many cycles are there? That is called its frequency. So if we put this periodic time or cycle time is capital T, then how many cycles per second? Now suppose this 1 cycle is 1 second. So it is up to here. 1 cycle is up to here, not here. It is from here to here, 1 cycle. So capital T is 1 second. Suppose it is 0.1 second. This is 0.1 second. Then how many cycles are there in 1 second? How many cycles are there in 1 second?
10.
Yeah, 10. Because 1.1 second, 1 cycle is there. In 1 second, 0.1, how many 0.1s can be there? 10. How did you get that one? So you can write the equation for this one. So number of cycles per second is called the frequency. Number of cycles per second is called the frequency. So we can write the equation F is equal F is equal 1 over T. Now we can put this equation for this one. That is F is equal F is equal 1 over 0.1. 1 over 0.1. 1 divided by 0.1 is 10. 1 divided by 0.1 is 10. Suppose this period is equal 0.01 seconds. 0.01 seconds. Then what is the frequency? Can you type your answer?
100. 100.
100.
Yes, 100, which is frequency is equal, you can put to this equation, 1 over 1 divided by 0.01, that is 100. The unit is hertz. Unit is hertz. Okay. Right. Now I put in a different way. Suppose frequency of a signal is frequency of signal is 1 kilohertz. So I will put a different way. Frequency of signal is 10,000 hertz. What is the cycle time or the period of the signal? You can use this equation. F equal 1 over T, then what is the T? T equal 1 over F. T equal 1 over F. Mathematically thinking is very important. Then only your analytical power will be increased. Then this is equal 1 over 10,000. That is equal 1 over 10,000. Okay, let me see the answers. Right. 0.0001. Very good. Maliti correct. Kanmoni correct. Gad is very good. Okay. HB Sedaviratna correct. Okay. Very good. That is 0.001. Sorry, let me see. Seconds. Now remember, always the frequency you have to take in hertz. If the frequency is 1 kilohertz, what is the periodic time? 1 kilohertz?
Kilohertz convert to hertz.
Yes, convert to hertz and see what is the frequency. Sorry, the periodic time.
Ten kilohertz.
I am asking the periodic time. Number of kilohertz is given. It is 1 kilohertz.
0.001 seconds.
Yes, correct. Yeah. Anjana correct. Sumudhu correct. KB Silva correct. Okay, very good. Okay. That is, we had first converted to hertz. That is 10,000 hertz. F is equal, so 1000 hertz. Then 1 over 1000 is 0.001. Right? So these basic parameters you should familiar, right? In the so these things actually you studied earlier. I don't want to repeat, but I'm going to refreshing because these basics are very important to understand everything. So now you know the cycle or the cyclic time or the periodic time, frequency. Then I will come to, then I will go to your book. Okay, now this signal F is equal 1 over T or T is equal 1 over F. So you can read this paragraph. In frequency is the rate of change with respect to time. Change in a short span of time means high frequency. Change over long span of time means low frequency. Okay. Then I go to another one here. So we can show mathematically that any signal is a combination of sinusoidal signals. Any signal is a combination of sinusoidal signals. There is something called the Fourier series and Fourier transformation. So mathematically, we can show that. Now you see this signal. This signal is we can show mathematically combination of these three signals. These three sinusoidal signals. So what are the frequencies? F, 3F and 9F. These three sinusoidal signals. So understand that any signal is a combination of sinusoidal signals. Not only analog signal, even digital signals. Right? So when you combine these three signals, the shape of the signal is coming like this. So now this representation is called the timed domain representation. That is your y-axis is the amplitude, x-axis is the time. So we can represent the same thing in frequency domain. When you are representing in the frequency domain, your y-axis is amplitude and the x-axis is the frequency. Now here there are three frequencies, F, 3F and 9F. And you can see the F frequency amplitude is high, that's why this high value here. Then the 3F extra is high and the 9F small value here, right? So the is also called, when you take this lowest one is called the fundamental frequency, others we call normally harmonics of the signal, right? So when you take any signal, it's combination of many signals. So now consider any signal, it has this frequency. So this is a frequency domain one. It has all these frequency components in that signal. Then this particular signal, the lowest frequency is 1000 Hertz and the highest frequency is 5000 Hertz. Then difference between the highest and lowest is called the bandwidth of the signal. So all these are relevant to periodic signals. Non-periodic signal I am not going to touch, just to understand only the periodic signals. So therefore, any signal, you should have some idea about what is the bandwidth of the signal. It is very important. When you consider digital signal, that also getting this kind of frequency components. Only thing is, it has infinite number of frequency components are there. But practically, you don't want to transmit infinite number. You can transmit few components, the fundamental and few harmonics, or even the fundamental one is okay, right? Now, when you understand what is a frequency bandwidth, normally we call bandwidth, and also any signal has many sinusoidal signal components with different frequencies and the different amplitude. The difference between the highest frequency and the lowest frequency is called the bandwidth of the signal. It is called the bandwidth of the signal. Right? Is it clear? Any question? Any question from this? Okay, now
So C summon F lambda means V summon F lambda, no?
what?
V summon F lambda theorem.
Okay, I don't touch those things. Just understand what I am telling now, right? Okay, I will come one by one. Here the V summon F lambda, you studied the what is lambda. That you can study by yourself. This one I am not going to explain that one because everybody studied that one earlier, right? I am teaching only the things, not very fundamental thing. In the O level, you studied the V equal F lambda, right? Because I don't have time to teach everything. Okay, now I am going to teach another important thing of a sinusoidal signal. The sinusoidal signal is a periodic signal. This period can be mentioned from a circle like this, right? This circle I can put in this way. This circle I divide into two parts here, then the A parts here. How many angles is there around this circle? How many angles are there?
360.
Yeah, 360 degrees, right? Or we can say 25. In degrees, it is 360, right? 360 degrees is there, then I divided, this is 0. This is 90. This is 180. It is 270. So this one period can be represented from a circle. Then you have having an angle here. 0, 90, 180, 270 like that. Then I can draw this one, this diagram like this. It is in the x-axis and the y-axis. I can, this is the x-axis. This is the y-axis. So then I can draw this one. Now this axis is voltage or the amplitude. Amplitude can be measured in voltage. The x-axis is the angle. This axis is angle. Angle you can write in degrees. Then this is, it is 0 degrees. What is the angle here? Can you tell somebody? This is a 1 cycle. It's 1 cycle. What is the angle here?
360.
This is
360. Correct.
Is
Here, what is the angle?
180.
180 years. Okay. Here it is angle is 90.
90.
Now in this circle, I can show this one. Same thing. The 0 is here. 90, 180, 270. You can represent it this way also. So when you put a circle like this is called a phasor diagram. This is called phasor diagram. Phasor diagram. When you say this signal, this angle also called phase. Angle also called phase. So this is phase angle 90, 180 like that. The same thing you can represent from this circle also. So when you take a signal, it has a phase angle or the phase, right? So now we discuss about the signal as a frequency, signal as an amplitude, signal as a phase. The phase also have some importance for wireless communication. Phase also have importance for wireless communication. Okay, now I'll take a signal. I'll take a signal and so this is x-axis, say. It's another one. I am taking the sinusoidal signal like this. I draw the first signal starting from 0 degrees. 0 degrees, this is the first one. Second one, I am starting with 90 degrees. It is this is not according to the scale. Third one, I started with the 180 degrees. Suppose the same frequency signal. Now here, there's an important point. These are their phase. X-axis is phase, y-axis is phase. Now, this signal and this signal have the same amplitude. All three signals have the same amplitude and same frequency. Is these signals are similar or the same? Can we consider these are same? It has same amplitude. Say amplitude is 5 volt. say frequency is 100 kilohertz. Is there a difference of these three signals? Yes, you can see some difference. That difference is called the phase difference. Phase difference. Now, phase difference between the first signal and the second signal is 90 degrees. It is 90 degrees. And second and third also have 90 degrees. First and third is having 180 degrees phase difference. Right? Phase wise, these are different. Now, that is the phase angle, right? So that also can be represented in a circle. Like here, in this circle, you have 0 here, 90 here, 180 here. The first one's phase angle represent here, second one phase angle represent here, third one phase angle represent here. Now, importance of this one is when you add first one and second one, so third one, what will be the resultant signal? Now, very first point, amplitude is 0, this is 0, right? 0 plus 0 is 0. Then take the second point, I'll take here. Suppose this amplitude is plus 5 volt. Yeah, 5 volt. Now this amplitude is minus 5 volt. So if you add these two, what kind of signal will come? If you add these two, what is the amplitude of the resultant signal? Plus 5 and minus 5 is 0, no?
0.
All are 0. It is just a straight line. Right? Now, in the wireless communication, this is very important. That is, in the wireless communication, suppose you have a mobile phone here. Here you have a mobile phone. And you are sending the signal to another person, another mobile phone. Here. Another mobile phone here. Right? Now there is a building here. So when you send the signal, this signal can be come directly to here. And this signal can go to this building and reflect it from here and come to here. Now these two will be combined by this received phone. When they are combining, if the phase difference is 180 degrees, what will be the resultant signal level? 0.
Zero.
So when the mobile communication, we are moving. While we are moving, always the recipient's phase, the resultant phase are different. So resultant amplitude will be different. Therefore, the signal will be fluctuated. Signal level will be fluctuated. So that is a problem in the mobile communication. That's why we are studying these parameters in the signals. So signal analysis is very important for this part, right? So any question up to here? So this is very interesting actually. So you can read this chapter of the book. Phase, it is explained the phase. Phase describes the position of the waveform relative to time 0. Right? Now you understand the importance of the phase. The wavelength, I am not going to explain, everybody should know that one. In the time and frequency domains, I explained. Then the bandwidth of signal, I explained, that also very important. Then the digital signals, normally we have 2 levels. So there can be signals with multiple levels. Now in this particular one, 1, 2, 3, 4, 4 levels are there, right? Now to represent each level, if it is only 2 level, you can have 1 bit. If it is 4 levels, each level can be represented from 2 bits. Now this is the signal level, this is the data bits, 2 bits you require for that one, right? Then the bit rate. So bit rate means how many bits are there in 1 second. So you can send a digital signal. In the digital signal, so you can send the digital signal. Okay, 1 bit. The time of 1 bit is called the bit duration, right? Suppose the duration of 1 bit is from here to here, say 0.1 second. This is the bit duration. Then how many bits are there in 1 second? This is similar to frequency. Bit duration I can write it in T. It is 0.1 second. Then the bit rate is how many T's are there. Bit rate is equal to 1 over T. Then what is the bit rate here?
Bit rate is 10 bits.
Yeah. 1 divided by 0.1. That is 10 bits per second. So when you take the digital signal, we are measuring that from the bits per second. 10 bits per second, 100 bits per second, then 1 kilobit per second, 1 megabit per second. And the bandwidth of the signal depends on the bit rate. How do you measure the bandwidth of a digital signal? How do you measure the bandwidth of a digital signal? We have to convert this to the analog signal, sinusoidal signals. Mathematically, we can show that if the time period is T, if the period is T, the fundamental frequency is 10 Hertz. Then the other next one is 30 Hertz, 90 Hertz, like that. It is increasing. So fundamental frequency is sufficient to send a digital signal. So when the digital bit duration, normally not this one, it can be 1 bit can be considered as a like this. This total part is a 1 bit. From here to here, 1 bit. So there are some theory part. I am not going to explain those things. So we can show that the bandwidth, the fundamental frequency of a digital signal is equal to half the bit rate. Half the bit rate. So if the bit rate is say 100 kilobit per second, 100 kbps, then the required bandwidth is half of that, that is 50 kilohertz. You need a 50 kilohertz bandwidth. So there's a relationship between this is the minimum bandwidth you require. If it is 20 megabit per second signal, what is the required bandwidth? What is the bandwidth of this signal? Can you type the answer? 20 Mbps. What is the minimum? What is the? Normally when you say the bandwidth, that is the minimum bandwidth. What is the minimum bandwidth? Bandwidth is measured in hertz. Right? What is the minimum bandwidth? Half of this one, that is 10 megahertz. 10 megahertz. Right? So by just looking the bit rate, you can think about what is the bandwidth of this signal. Right? So this is very important. Then why we say this bit 20 megabit per second bandwidth? Normally when we are talking, we call the bandwidth is 20 megabit per second. No? But actually that is not correct, but we are using that term because there's a relationship between the bit rate and the bandwidth. It's a linear relationship is there. So therefore, normally even the bit rate we say the bandwidth. Right? But actual way, bit rate is something, bandwidth is something. Right? Is it clear? Any question? Any question you have? Is it clear?
Yes, sir.
Now you can see these are fundamental theories I am doing, and the bit rate I explained. You can read this one. And now here is a good question is again, what is the bit rate of high definition TV, HD TV? What is the bit rate of high definition TV? How do you calculate that one? The TV screen, there are 1920 by 1080 pixels per screen. 1920 by 1080 pixels. What is a pixel? So what we do is suppose this is the TV screen. We divide this to very small squares. Like this. Right? So this is a 1 pixel. So this one is this one. K is 1 pixel. Now in this question, how many pixels are there? 1920 into 1080. 1920 into 1080. It is this way, it is 1080 columns. 1080 columns into 1920 rows. Then how many pixels are there? Can you type the answer? Just multiply and no need to simplify. 1080 columns and 1090 rows are there? How many pixels are there? Okay, Shakti's answer is correct. What you are doing, you have to multiply this one, right? The number of pixel is 1080 into 1920, right? 1000. No need to multiply, just put it there. Now this question says it has that much of pixels per second and the screen is renewed 30 times per second. How many screens are coming in 1 second? 30 screens per second. First we calculate the number of bits in one screen. Now this much of pixels are there. Now when you take 1 pixel to represent the brightness of this one, you need some amount of bits. And to represent the color, you need some amount of bits. Normally for the brightness, you need 8 bits and the colors, you need 16 bits. Now here it says, so in this question, it says, it is 24 bits represent 1 color pixel. So normally 8 bit for the brightness and the 16 bit for the color. So 1 pixel represents 24 bits. 1 pixel represents the 24 bits. Right? Then there are this much of pixels. How many bits are there in one screen? 1 pixel is 24 bits. One pixel equal 24 bits. Then how many bits are in one screen? The one screen is this much of pixel. One screen is how many bits? No need to multiply, and we just put with the multiplication. So 1 pixel is 24 bits. There are 1920 to 1080. Nishamali is correct. Shakti is correct. Okay, Shakti is very good. Himesha is correct. Not Himesha is not correct. Gayan is correct. Gayan is good. Yeah, okay. So now this is the number of pixels. This is 1 pixel. How many bits? Then the number of bits is the 1080 into 1920 into 24 bits. These are, you don't want to, these are actually the common sense. So simple calculation. Only thing is now these days students are not thinking, always try to search and find something. So my subject you can do, you cannot do in that way. Okay? Now this is for one screen. In 1 second, this screen is refreshing 24 times. In 1 second, this type of screen, 24 screens are, let us see how many screens are there.
30 screen.
30 times per second, yes, renewed in 30 times per second. 30 screens are coming in 1 second. Then can you calculate the bit rate? What is the bit rate then? You can type your answer. Okay, Gayan, very good. Shakti, very good. Yes, your answer is correct. Vaimi, Pyubi, correct. Okay, very good. It seems you understand properly. Then it should be multiplied by 30. That is the bit rate. Then what is the required bandwidth to send this signal? Or else what is the bandwidth of the signal? I told you bandwidth is half the bit rate. Then you divide it by 2, that is the bit rate, bandwidth of the signal. Right? That is the bandwidth of the signal. I will go to the book now. Right. This is the bit rate. So it's approximately 1.5 gigabit per second. Then the required bandwidth will be 0.75 gigahertz. Required bandwidth will be 0.75 gigahertz. But when the TV stations transmitting this signal, it is not going to such high bit rate. They transmit the same thing from a low bit rate such as 20 to 40 megabit per second. How it is doing? How they reduce the bit rate? By compression techniques. Have you heard about the compression techniques? Yes, there are many compression techniques. From compression techniques, they reduce the bit rate. Now, this is the HD TV. The 4 times resolution of this one is called the 4K TV. 16 times resolution of this one is called the 16K TV. Right? Now, there are 4K TVs and the 16K TVs. Their resolutions are very high. So, if the screen is small, you don't see any difference between the HD TV, even the standard TV, standard signal, you don't see the difference. The screen is small, right? Any question up to here? Right? Now, you understand the analog signals and the digital signals and their characteristics, right? Okay, question is asked how to calculate the bandwidth. You take the half the bit rate. If the bit rate is 100 bit per second, then the bandwidth will be half is the 50 hertz. If the bit rate is 100 kilobit per second, then the half is 50, that is 50 kilohertz, right? Approximately you can get it that way, right? Okay, you can see that we have started with very simple theory part. Now we are coming to gradually little bit complicated things, right? Now these things are important to understand understand the wireless communication. Then I will show you that we have done the analog to digital conversion and the data and signals, and the data and signals also some other important transmission of digital signals. So when the digital signal is going through a transmission media, this transmission media also have the characteristics. Transmission media is just like a road. Digital signal is just like a vehicle, right? Understand the scenario. Transmission media is just like a road. Digital signal is just like a vehicle. Now, can you drive a container in an 8 feet road, small by road? You cannot drive, no? The reason is the width of the road is less than the width of the vehicle. Similarly, now this transmission media also have some bandwidth. All transmission media do not have the same bandwidth, right? If you take a small gauge the small diameter copper cable and the big diameter copper cable. Big diameter copper cable has a higher bandwidth. So therefore, when you are sending a signal to a transmission media, you have to check the signal bandwidth as well as the transmission media bandwidth. We have to check the signal bandwidth as well as the transmission media bandwidth. So there are mathematical ways to calculate these things. So we have to make sure that the transmission media has a higher bandwidth than the signal bandwidth. So to calculate the signal bandwidth, there are methods. To calculate the signal bandwidth, you can use the Shannon law. There is an equation for this one, and right. When the signals are going through any transmission media, it is face some problems. These are called the impairments. One is attenuation, other one is the distortion, other one is it is mixing with the noise. These signals are when it is going through the transmission media. One is the attenuation. Attenuation means the energy level is decreasing. When the signal is going through a transmission media, its energy is decreasing. Why energy is decreasing? When it is the copper cable, the signal is a current. When a current going through a copper cable, it is the thermal energy dissipating I squared R, heat energy. So that means part of the signal is converted to heat. Therefore, the signal level is decreasing. This concept is called the attenuation. Do you understand what is attenuation? Is it
Yes.
clear? Right?
Yeah.
So these things can be explained in very complicated way also, right? So this is a simple way. In the optical signal also, there are ways to losing their energy. It can go out from its core, and the different ways are there. So attenuation is a problem of a transmission signal. So consider this signal, this analog signal, when it is going through the transmission media, its signal level is coming down. I told you the signal level depends on the amplitude, right? It is coming down like this. By using the amplifier, you can amplify, signal level can be increased again, right? To measure these things, there is a unit called the decibel, dB. I'm not going to explain that term, we don't have time. So, then the distortion. Another impairment is the distortion. So I told you that the frequency, any signal is a combination of sinusoidal signals. Any signal is a combination of sinusoidal signals. Now this signal I showed you earlier, it has 3 frequency components. Now thing is, the speed of the signal through a transmission media depend on the frequency. So understand this one. Speed of the transmission media within the transmission media of signal depends on the frequency, right? So therefore, when we send the signal, this large amplitude signal, it's come to the destination like this. Other one may be little slow. Now you can see they start with the same phase, but the second one, it's not come yet. Little bit more to come. Then there's a phase difference. Third one also have a different phase. Now phases are changing now. When it is come to the destination or the receiver, phases are changing. So when you mix up this one, because the to construct the original signal, we have to mix up these three. When it is mixing up, its shape is changing. Now, this is the original shape, and this is the received side shape. You can see the signal shape distorted. It's changed. It's called the signal distortion. And this different times it takes to travel, that is called delay. So maybe the largest, highest speed one, highest amplitude one, the highest speed or other way around. Then the first thing and the second thing, there is a delay is there. So delay is a problem in the digital signals. Delay of signal is a problem in the digital signal. Because of that, signal can be distorted. Because of that, signal can be distorted, right? Then the two problems we have, one is the attenuation, other one is the distortion. Next one is the noise, right? So noise means unnecessary signal. When I am talking here, so that is the signal you need. If the other students also talking, it is a noise for you because they are unnecessary signal. Similarly, noise is an unnecessary signal. How the unnecessary signal mixing up with our useful signal? It is easy to explain in the copper cable. In the copper cable, it is going as an electric current. When it is how the electric current is flowing in the copper cable? What is moving there inside the copper cable? Current is what?
Electrons. Electrons.
Yes, good. It's an electron movement of electron. But there are free electrons within the copper cable, inside there. They also move, free electron moving. So that movement also current. That current is unnecessary signal. Right? Now you can see how the noise is generating there. This is one way actually. This is called thermal noise. Right? Then our signal is mixing up with the noise, and again it will be some kind of distortion is there. Right? So check the quality of the signal. We use the parameter called the signal to noise ratio. So that is the average signal power divided by average noise power. So that also measured in dB. Right? Then the data rate limits. The limit of the data rate, if the no noise is there, the bit rate is equal to 2 into bandwidth into log base to L. L means the how many levels in your signal. Normally we have 2 levels, therefore log base to 2 is 1. You can have 4 levels digital signals or theoretically, or 8 level. If it is 4 level, log base to 4 is 2. If it is 8 level, log base to 8 is 3. Right? So if there is no noise, this much of bit rate can be there. Right? If it is 2 levels, this log base to L is 1. Then you can say bit rate is into 2 into bandwidth. Again, the bandwidth is equal to bit rate divided by 2. That's what I told earlier. Bandwidth is half the bit rate. Right? Some examples are here. If it is a noisy channel, noiseless channel is a hypothetical thing, but actually there are noise. If there are noise, the bit rate can be calculated in this way. Bit rate can be, this is the equation you can bandwidth into log base to 1 plus signal to noise ratio. Right?
So what is log base to?
What is log?
I mean, do we need to know that, or it's just a complicated thing?
No, not necessary, but log is why you use the log tables. Now those days there were no calculators, right? So when we are in the school, we did not have calculators. We use the log table. So log means now say you want to multiply by 2 into 3, that is 6. But 2 divided by 3 is difficult to sorry, multiply, no, the addition is easy. Therefore, what you do is you will convert all the numbers to what is the 10 to the power value. For instance, 100 is 10 to the power 2. The log base 10, 100 is 2. Normally log is the base 10. Now log base 2, 8 means that is what is the power level. So now log base 2 with the 2 to the power. What is the value of 2 to the power? Log base 2, 8 is 3. Because 8 is 2 to the power 3. Log base 2, 16 is 4. Right? Is it clear?
Yes, yes.
Okay, these are fundamentals actually, but unfortunately in the school we don't properly study the fundamentals, right? Then you can read this one. In practice, we use the both method to find the limits and signal level. Let us know this example. Please read this one. We have a channel with the 1 megahertz bandwidth. The signal ratio of the channel is 63. What are the appropriate bit rate the signal level? So we can calculate in this way. In the other equation, okay, I will not explain this one today, but just read it. From that one only, from these two equations only, you can decide what is the maximum bit rate you can send through the transmission media, right? From this way, you can say Shannon formula, what is the upper limit, maximum rate you can send through the transmission media. It depends on the signal to noise ratio and the bandwidth of the transmission media. B is the bandwidth of the transmission media. And then you have the other equation, how many levels. With the number of levels you have, what is the maximum bit rate you can use. So you have to get the lesser value here. Just read this part there. Okay. Now I go to my book. Right. Okay, you can refer this book also. Where the analog signal, I explained this one. Then the noise, it can be mixing up with the noise. When after traveling some distance, original signal mixing up with noise, then when the distance is increasing, more noise will be added to the analog signal. When you amplify, noise also amplifies. Then the digital signal is like this. The digital signal also, when it is going through the transmission media, because of the attenuation and the distortion and the noise, it can be also changed like this. But the digital advantage is it has only two levels normally we use. Then we just check what is it is low or high. Then you can reconstruct the signal. By that way, you can remove the noise completely. Then we discuss how to convert the analog signal to a digital signal. Then I explained you the amplitude, frequency, and the phase. You can read this one also. Modulation I did not do today, but I do the modulation later. From this book, you can refer that part. Then I will refer our course plan. This is our course plan. Protocol standards, OSI model, TCP/IP protocol suite, analog signal, digital signal, transmission impairment we have done. Analog and digital transmission concepts. Multiplex in this part I could not still do, but next week I hope to finish those parts. Okay, any question? The question are do we use repeaters for amplification or is there any other? Yes, we are using the repeaters for amplification. So when you take a switch, layer 2 switch, amplifier already inside there. Right? Okay, any question? It is too much for you. Is it clear? Okay,
Yes.
no. Hmm?
Actually, do we need to memorize all those formulas as well for the exam?
Not necessary.
Uh-huh. Okay.
Understand the concepts. I'll give some questions. Last time also I gave a tutorial. Today also I give the tutorial. So yeah, if you answer to those questions, you can ask the MCQ questions and your assignment 1, you answer to these questions and submit the hard copy. You can upload it, right? Not there is separate one. Now the tutorials will be the assignment 1. Just put the answers and you can upload it.
When is
MC
the deadline period?
So still I didn't give the assignment. After I give the assignment, I give a deadline. The assignment is combination of all these things. I will tell you when the deadline. Okay.
There is already a tut in the course web.
Yes.
Is that assignment
Yeah,
or-
that is the part of assignment. Okay.
Okay.
This is dual purpose. For the first test, MCQ test, the questions are coming from those areas.
Okay.
But you don't want to completely study all these things in the book because this is wireless communication. So you can understand the concept. Okay, you can put your attendance now.